Hello everyone, my name is PRIYANKA and today I'm going to cover the topic of bias and variance in this presentation. So starting with what is bias and what is variance. So we'll start with bias. So what is bias? So bias and variance are used in supervised machine learning in which now the algorithm learns from training data or a sample data set of known quantities. So the correct balance of the bias and variance is vital to building machine learning algorithms. Now, to make predictions, our model will analyze our data and find patterns in it. Now, using these patterns, we can make generalizations about certain instances in our data. Now, like our model after training learns these patterns and applies them to test set to predict them. Now, bias is the difference between our actual and predicted values. So, bias is simply simple assumptions that our model makes about our data to be able to predict the new data. So, this is all about bias. Now, we have been thinking about average error in terms of in sample and out sample, but this depends on a particular training data set. So what we want is a concept that extends to all possible training data and captures the performance of the estimator in that setting. So for example, our ultimate estimator F is derived from a particular set of training data D and is thus denoted F of D. Now, this makes the out sample error explicitly E out FD E out of FD. To eliminate the dependence on a particular set of training datasets, we have to compute the expectation across all training datasets. Now, as you can see, ED, E out of F of T is equals to bias plus variance, where bias of X is equals to F of X minus F of X 2, and variance of X is ED of F of D of X minus F of X 2. So, where F is the mean of all estimators for all datasets, and there is nothing to say that such a mean is an estimator that could have arisen from any particular training data. It just implies that for any particular point x, the mean of the values of all the estimators is f of x. Now, next is the variance. Now, what do we mean by variance? So, during training, the model is allowed to see the data a certain number of times to find the patterns in it. Now, if it does not work on the data for long enough, it will not find patterns and bias occurs. So, on the other hand, if our model is allowed to build the data too many times, it will learn very well for only the data. Now, it will capture most patterns in the data, but it will also learn from the unnecessary data present or from the noise itself. So, we can define variance as the model's sensitivity to fluctuations in the data. Now, the model may learn from noise, but this will cause our model to consider the trivial features as important. Now, as you can see, the model will perform really well on testing data and get high accuracy, but it will fail to perform on the new unseen data and the variance may occur. Now, next we cover base variance trade-off. So, for any model, we have to find the perfect balance between the bias and the variance. So this just ensures that we capture the essential patterns in our model while ignoring the noise present in it. Now this will help optimize the error in our model and keeps it as low as possible. So an optimized model will be sensitive to the patterns in our data, but at the same time, we will be able to generalize to the new data. So in this, both the bias and variance should be low so as to prevent overfitting and underfitting. Now, error in training and testing with high bias and variance. Now, this image shows the error in training and testing with high bias and variance. So we can see that when bias is high in the image, in the given image, we can see when the bias is high, the error in both testing and training set is also high. So if we have a high variance, the model performs well on the testing set. We can see that the error is low, but it gives high error on the training set. So when we see that there is a region in the, we can see that there is a region in the middle where the error in both the training and the testing set is low, and the bias and the variance is a perfect balance. Now, linear regression. Now, what does the linear regression mean? So it is a machine learning algorithm based on supervised learning. It performs a regression task. Now, models a target prediction value based on the independent variables. So it is mostly used for finding out the relationship between the variables and the forecasting. So different regression models differ based on the kind of relationship between dependent and independent variables. So they are considering the number of independent variables being used. So linear regression basically performs the task to predict a dependent variable y on a given independent variable x. So here x is the experience of the worker, okay, that is independent variable, whereas y is the salary of the worker, which is a dependent variable value. So this regression technique finds out the linear relationship between x input and the y output. So this is all about linear regression. Now next we will be covering the mean square error. So mean square error is the average of the squared error that is used as the loss function for least square regression. So it is the sum of all data points of the square of the difference between the predicted and the actual target variables, that is divided by the number of different data points. So there is a zero bias and zero variance when x is equals to 0. This is only because the learning method cannot help but get that correct because all the hypotheses happen to match the value of the target function at that point. So likewise, the variance is 0 because all possible pairs which constitute the training data fitted through 0 because h of x is equal to ax has no choice but go through 0. Now here in the given example, we can see the predicted values are points on the line. The actual values are shown by the small circles. Now error in prediction is shown as the distance between the data point and the fitted line. Now, mean square error for the line is calculated as the average of the sum of squares for all the data points. Now, for all such lines possible for a given data set, the line that gives the minimal or least mean square error is considered as the best fit. Now, what do we mean by bias variance decomposition? Now, bias variance decomposition is the way of analyzing a learning algorithm's expected generalization error with respect to a particular problem as a sum of three terms. That is the bias, variance, and a quantity called the irreducible error, resulting from the noise in the problem itself. Now, this is something that you can approximately measure experimentally only if you have a synthetic data or you need to show somehow approximate ED HD of X. That is, construct many variants of the database. Now, with the help of this on the topic bias variance, I've implemented the code in Jupyter Notebook, as you can see. So these are the different libraries that I have imported. So as you can see from SciPy, I have imported stats. Now from sklearn, the library that I have imported is linear regression. The NumPy is the library that I have imported. Now we have defined the sign data n is equals to 2. Now we have defined a random variable that is x, where we have stored the stats.uniform from -1 to 1. Now we have generated a sample v is equals to x.rbs n from n to 1. So in the variable v, whereas we have used the sample for the sign. As you can see, this line y is equals to mp.sign. So in the variable y, and then we have mentioned returned y, v, and y. Now here we can see LR is equal to linear regression, fit intercept is equals to false. So what does this mean? So fit intercept means the intercept is forced to the origin 0, 0. Now as we can see, the LR.fit, that is sign data of 2. Now what does this mean? Right. So we have designed assign data to return a tuple to use the automatic unpacking feature of Python functions in LR fit. Now, in other words, using the asterisk means we don't have to separately assign the output of the sign data before using them for LR.fit. So as you can see here, we have used the asterisk sign here. So linear regression, copy x is equals to 2, fit intercept false and normalize is equals to false. Now, using the linear regression object, we can compute all the A parameters. Now we can see the next line is LR.coef. Now coef is an attribute of linear model which gives only coefficient on features in the decision functions. Now here as we can see, this is an np.array. So using this array, logical logical operations can be performed using the array. Now as we can see that we have also used LR. Now A underscore out is the output container where we will be storing the output for I in the range of 100 as mentioned here. Now we have used lr.fit sign data. So lr.fit, so it fits a linear model with a coefficient to minimize the residual sum of squares between the observed target in the data sets. So now we have also used the aout.append. So the in the above line lr.fit, the logistic regression model stores the coefficient of predictor variables in lr.coef, whereas a underscore out.append lr coefficient 0, 0. So in this, the logistic regression model will store the coefficient of predictor variables. Now in append, we have also used append. So append is a list of functions basically used to append a value at the end of the list. And this is the output. So approximately it should be 1.43. So let's see by running this code. Now, as we can see, the current output is 1.50. So we will run this again. As we can see now, the output has been changed. That is 1.62. The approximate should be 1.43. So this keeps on changing. We can try it once more. As we can see, again, the output has been changed to 1.56. So this output keeps on changing as many times you make the iterations. So using for the specific situation, A approximately should be 1.43. To get this value, we just loop over the process. We collect the output and average them. So we have to loop over many more iterations to come close to the proposed value. That's the reason we did it. We can see that whenever we run the program, the output keeps on changing. So this is topic that I have covered, that is bias and variance. So thank you so much.